When there is no air, nothing happens to this paper, right? When air is coming, it deflects. Why it deflect? Where does this thing deflect? Drag. Where does that drag come from? Air? No air here. Air or air movement? Because if there is air, but nothing happens to it, right? Once we move, then force will start to develop. Okay? So this drag is mostly come from the movement of the air. Okay? When it is slow, it is good for you, right? You want to have heat dissipation to you. You are sitting next to your desk fan, right? Or you do here we got aircon, so no problem. During my undergrad, you don't have this kind of thing, so you need to do this every time, right? We focus more on this rather than the lecture. What the hell, lecture say, well, I don't care, it's too hot now, right? But here we are lucky, we got aircon, so we don't do that. So, so this force is coming from the moving fluid, okay? Usually it is undesirable. Usually you want to minimize it. When you design a car, you want to minimize the drag. When you design an aircraft, you want to minimize the drag. When you do a racing, you want to minimize the drag. You know, Usain Bolt, when he runs, what happened? Do you see the hand movement? Do you do that? Do this. Right? Slicing the air. Slicing. Right? Any one of you run with this? Alright? Right? Boys or girls, when you run at high speed, you will have your body slanted to the front. Right? Like that. Unless you are special. Yeah, you are special, then it's totally different. But usually you will try to do that and your hand will not be like that. It will be this. Because naturally we want to minimize the drag. Naturally. Okay? Naturally we want to minimize the drag, but at some condition you want to maximize it. Okay? If you look at the paratroopers, they do not want to minimize the drag. Right? Because if you minimize the drag, okay? So sometimes you want it, but most of the time you do not want it. Okay? Usually you do not want it when you need the speed, but during the brake, you want to have it. If you know the Bugatti Chiron and Veyron, 80% of the brake does not come from the Brembo there, on the disc brake. It comes from the spoiler, the air brake. The same goes for the aircraft. Most of the aircraft brake not come from the one installed here, but the one installed there, air brake. Okay, because that one is needed for that purpose. Okay? The same goes for the lift. How to make your aircraft flying? Can you fly this thing if you are having a vacuum work? No. Impossible. If you are living in a vacuum world, those big things will not work. At first. Second, those wheels got no use. So what is the source of this lift? is again the air movement. Kite. Wow. What else? Okay. So let's take a look at this kite. You have those kites. Okay. This is your kite. Now I need your imagination skills, right? Imagination skills. This one is your kite, right? You ask your friend to hold it. You hold the wire or the thread, then take off. It goes like that, right? So now you have learned static, right? Yes. What is the force working on it? Tension. Then gravity. Weight and gravity, yes. Thrust. Where do the thrust come from? You do not have the engine on it.
When you run it, sir.
When you run it.
Yeah.
When you run, the thrust is coming.
Yeah. Eventually, yeah.
Okay. Okay. Then the drag. Okay. Now you have your kite. Okay, I do not know how to draw that kite nicely, so I just draw it like this. This is your kite. This is your tension. The air is coming from here. Okay? When the air is coming, it will be deflected to that direction and this direction. What's that? How to explain to you? Air is coming, my boy. And then goes up and goes down, right? So this air is something that make it airborne. Airborne. Flying. Because this will provide the friction on it, push it there. This will push it there. Now the problem is you have two components and each of these components has Y, X,
Z.
Z lah. We are talking about V only. This one X, Y. So that is what we will use in this class, right? So the incoming flow is like this. This is your force, okay? When you have air coming from there will be a force working on this direction.
Yeah.
Or if you split it into two, okay, this one is your normal force, this one is your tangential force. Okay, now just to go a little bit deeper, when you have this kind of thing, the air is coming from here, the force will be a tangential force. Okay, and this tangential force is nothing but your shear stress. Okay, and this shear stress is the one that will make you stress during your exam. Okay, this is your shear stress. Now, if you put it like this, the flow is perpendicular to the plate, then you don't have a tangential component anymore, but you will have a normal component. And this normal component most of the time is the pressure. Why it is called pressure force? Because it depends on the pressure difference between the front and the back. Front, back. But if you have this, it is the shear working on this. Okay? So when it is parallel like this, you have the tangential. When you have normal, you have the pressure. Okay? And what does it mean? Okay. Now, like the case of your kite, some of this leaf, some of this force, tangential force, the one that walking parallel to the plate, will make it goes up and it will drag it back. Okay? Because the shear that goes to that direction will make it goes up. The shear that goes there, of course, it will goes down, and of course the shear, because it is on this direction, it will have that component, right, going to the back. So this component is called the drag. That goes up, goes down is the lift force. Yeah. Now that one is about the tangential force. How about the normal force? Because this air is coming not perpendicular to that, right? So it has the tangential component and it has the normal component. The normal component, if it goes to that direction, mean you will have goes up, lift, goes down, goes back, drag. So both tangential and normal, okay, provide lift and drag force. Is that clear?
Yes.
Only this, yes. Behind. Okay, you have a kite, air is coming. This air will provide pressure force and shear force. The shear force, because it goes here and there, it provides lift as well as drag. The lift is the one to the y direction, the drag is the one to the x direction. That one is the tangential. Now, the air is not only coming to that direction, but it can also come to that. I mean, this air has component on that direction and component on that direction. So now we are talking about the pressure component. The pressure component also bring it up and bring it back.
Yes.
So both tangential and normal force contribute to the lift and drag force. Yeah?